Hello guys, so good morning. Yesterday we went through some uh, development sessions. Alright, so we have gone through the installation part and all right. So today I'll show you how to connect those things and then try to do the job actually. Right. Yesterday if you of folks didn't attend these classes, so what I'll do is I'll try to request our the organization person, right? So Teja. So I'll try to ask him to share that particular video to you guys so that you can have an access for that. All right. So and then let me go through the schedule. So as per our schedule, so numbers. Let me open that. Give me a minute, guys. Hope my screen is visible to everyone. And if you have any questions, any doubts, feel free to stop me in any and you can post me there in the question area. So I'll be able to answer your questions. All right. Okay, so we have something called we started using uh, we have gone through the introduction part and then I have introduced Raspberry Pi yesterday. So today I would like to talk on some libraries which you can try, right? So I'll try to capture that. And then okay, so yesterday we were able to cover. Okay, so when you talk about Raspberry Pi, so here we have, right? So, and apart from the regular boards, there are 40 pins which are being given back to the user, right? So these 40 pins, right? You can try to configure them, and you can write some data to that pins, and then you can read some data, right? So writing the data means, for example, here in this case, you have an LED, right? You're trying to write some data. I mean to say, like, you are trying to switch on and switch off that particular LED. So if that is the case, you're trying to access that pin via some number. There'll be a number assigned to each of those pins, right? So if you want to access those pins, right? So here is a small C program which is available. But in our case, we would be going with the Python coding part, right? But in this case, let's say here it is a C code. All right. So C code, when you try to access, you need to write the code like this. All right. So you need to provide the pin number. So here in this case, 26 is the pin number which has been connected, or which it was connected. All right. So and then it is connected with the resistor back to the LED, and then we are trying to connect other part of the LED to the ground. Right. So for any DC device, DC device, we have something called positive and negative supply. Right. So same thing, we need to provide that in this case. Right. So negative will go to the ground. Right. Positive will be connected to the GPR number. All right. So here in this case, yes, it is. All right. So you can see this one. Okay, so you can see the GPI number. So in main method, we are trying to set up the method, and then we are trying to set one of the pin to output mode. That is like it is acting as an output. So in a any GPIO number means general purpose input and output. All right. So GPIO means same pin can act as an input or output. Right. So, but we need to mention it clearly whenever we are using it, whether you are using it for output purpose or input purpose. All right. So now let's say you have connected LED to this particular 26th pin, and then you are trying to do a job. All right. So you are trying to glue a job. So you're done with that, and you have removed your LED, and then you are trying to use the same pin as an input. All right. So let's say you have connected a sensor. Sensor is generating some data. That data can be captured on 26th pin. But in that case, in your program, you should mention that as input here. Okay. So you should mention that as an input here, and then we are going to run those things. All right. So we need to set that pin mode, and then while one is nothing but it's true always. Right. So it's an infinite loop. It keeps running. Right. While one. So he's trying to write the LED pin. So whatever LED pin is nothing but 26th pin high. High means the high voltage is going to provide the high voltage which is available on the board. All right. So in our Raspberry Pi case, it is 5 volts. All right. So in case of LED low, that is like 0 volts. We are going to provide a 0 volts back to the user. Okay. So and then we are going to delay it for 1 second so that the operation will be delayed by 1 second and then do the work. Okay. So this is how you're going to do it as part of your C program in the term. So once you've done this, once you wrote this, write this code, right, and then you need to compile that using this particular command, right? So you're going to compile GCC is a internal compiler which is available. Taco, and then this is a LED blink. This is an output one, and the what is the source? This is the output. This is a source file, and then you are trying to provide the libraries like so wire5 is a library which is available, right? You're going to provide all of those, and then you're trying to blink it. Once you've done this job, right? So you will have a executable LED blink application. So all you need to do is you just need to invoke that and then run this application. So dot forward slash and LED blink will do the job for you. So it keeps on running the and doing the job for you. Okay. Yes.
We have to include in the library as a while and we should comment.
Yes, you're going to install this WirePi before. So if you observe here, yes, we would be doing that as part of the installation application, WirePi installation, right? So first you need to upgrade, and then you need to clone that particular WirePi from this particular location, GitHub location. All right. So you're going to clone that, and then you're going to CD into that, and then GitHub pull, and then build. So once you build that particular application, nothing like it. So you have the way installed it. Right. So or otherwise, you can go ahead and click on this particular link, and then download that. So you would be going to this particular link, and then you can download that particular file. So for example, here we have the updated. So you have this particular WirePi. So yeah, tar file is available. Tar file is nothing but is another form of zip. So you're going to provide that. So once you have this particular tar, right? So you have everything here. So you can just we have this installation file, and then we have build, right? So you can just go ahead and build that application. So it will be built for your operating system. So normally with respect to C, we have that issues. Right? So you need to go with that and then do the job. Okay. Something is very wrong. So it has opened all the files which are there. Okay. This is the next code which is sorry guys. So we have the zip file which is available, so you can try that, right? So it is possible, and then that is all about the GPIO application. For example, if you want to do the same task with respect to C, Python language, right? So Python is what our concentration is, right? So you can go ahead and import something called RPA.GPIO, which is available on board. Alright, by default, Python packages are installed on the Raspberry Pi. Alright, with that Raspberry Pi, you would be getting this particular RPA.GPIO package, right, or module. So you're going to import that as GPIO, and then on that GPIO, these are the default things, guys. You need to run this particular thing. All right. So here we need to set the warnings to false, and then we need to set the board, right? So we need to have the type of mode what is available. We have two different types available. So one is board mode, and then the another one is BCM mode. So what is the difference means? Whenever you mention the board mode, right? we have a given pin, right? So we have something like so for a given pin, we have both two different versions of this particular thing. So let me show you that board versus BC. All right. Mm, okay, okay. This is better. All right. Do you see? Sorry for that. Okay. Do you see this? What's happening here? All right. So this is a 40 pin header. What you see as part of your Raspberry Pi. This particular 40 pin header. All right. So is given. It has been tilted here. So first one is a 3.3 volts. Right. So other thing up to 5 volts and 5 volts, and then all blacks are grounds actually. So you can see all the black colors. Right. All you see is the grounds. Right. So if you want to use the number which is available on these things, right? So on these things, all right. So this is called board mode. Okay. If you want to represent, call the, if you want to assign using the BCM board mode, right? You would be using the numbers, physical pin numbers, right? The physical pin numbers are the ones which you would be using as part of the board mode. In case of BCM mode, you would be using the number which is assigned to it. So here, let's say, for example, 36, it is GPIO 16, right? So then 16 would be the number what you give in the application coding part. So when you come back here, right? So here in this case, it is board mode, and the physical, this 32 is nothing but the physical pin number. All right. So and the switch is nothing but 29th pin. All right. So in this case, 32 is a board. 32 is the pin number. So here in this case, what is the GPIO number? Equivalent GPIO number 12. Right. So for example, if you are trying to do the coding as BCM mode, then the LED pin should be 12 in our case. Okay, got it? So that's the only difference you will find here, and that is for the easy, convenient for BCM is always better because it will clearly give you what is a programmable pin and what is a non-programmable pin. Power pins. All right, we have something called power pins that is like for 3 volts, 5 volts, and ground and all, right? So we have ground pins, and then apart from that, we have the GPIO pins, right? So BCM mode is always better because you would clearly know what pin you are trying to act, right? What GPIO pin number you are trying to act, right? Which is always good. But sometimes, like people are very much habituated to use the board mode, right? They normally use it.
So both are equal, sir.
Both are does the same job for you, but thing is, so in board mode you should be more careful. You should be more careful in this case. For example, let's say you have a ground pin, you are trying to apply 5 volts over there, which is not a good thing for you. Okay, that is virus actually. You can create virus for Raspberry Pi and saying that you're going to apply those voltages there. So that is a different scenario. I'll talk about it later, how to control, how to uh, what to say, like safeguard your Raspberry Pi, how to explore that and all, right? We'll try to deal with that in a later sections. But in this case, just remember, whenever you mention board mode, that is a physical pin number. Whenever you mention the BCM mode, then it is uh, a GPIO pin number, right? So just remember that. And here in this case, so these three will help us to set up that particular job. All right. So here in this case, we are taking two LED, one LED and one switch. Whenever you press a switch which is available on 29th pin, the LED is glowing, right? So it is glowing here in this case, right? So and then like once you're done that job, right? So here we are trying to read that particular GPIO number, right? So what is the value of it? And then take the same value and push it back into the GPIO number. Okay, so GPIO pin, so that it will act as a it will turn that particular thing on and off. So in your case, here in this case, we are trying to push it low for all the cases. Whenever the switch input is low, whenever it is high, we are trying to provide it as a high value. Right? So that is all about. That's about the Raspberry Pi. How to use the simple Python coding part. Right? So this can be executed using the internal editors or the plain terminal is also good. So when yeah, nano and then yeah, plain terminal is also good. Terminal from terminal also we can try to execute this command without any problem. Right. So I'll try to connect the Raspberry Pi tomorrow, and then we'll try to show that in a proper way. Right. So that should be good. All right, folks. So the equivalent C code is this one. So you can try that, but I would not be going with this particular job in this case. All right. So and then again, so this is all about the Python code. Yes, C and C++. Right. So in case of Python, so in case of C, he is using some local editor which is available. So you can try running these particular applications like this. Right. So you have compilers, you can try all of them. Right. So try running them and do the work. Right. So in Raspberry Pi, we can try setting all of that. Okay. So I would be sharing this document, guys. Please keep it as a reference because I would be coming into this again and again. Right? All right, online folks, I will be sharing it across the handles. So please wait for a second. Please pick it up from the handout section, so you can try checking that. Okay. The rest of things are all about how to access that particular application from a different locations and all. Right.
It is PDF, right?
Yeah, there's a video.
And WhatsApp.
Yeah, sure. Okay. So and then once you're done this job, right? Once you're done with the LED part, right? So we are going into the PWM mode, right? So PWM is nothing but pulse width modulation generation. For example, so you are trying to send the pulses, right? So here is a case, right? So whenever the pulse is having less width, right? So the size, I mean the intensity of the light is low in this case. Whenever it is white, that intensity of that is very high in this case. All right. So there are dedicated PWM pins which are available for us. So especially for this kind of operations. All right. So we have something called, for example, here in this case, we have 12, 18, and 13 and 19. So 12, 18, and 13 and 19. 12, 13 and 19, and this is 18 GPIO numbers, right? So these GPIO numbers will help you to do that particular job, all right? So especially for the variable resistance applying, like for example, if you want to slowly glow and slowly switch it off and then do the work and all, yes, you can do that. So something which is similar to the dim light, all right? So let's say you're trying to build some voice system, right? So you ask a voice assistant saying that, boss, you increase the intensity, or if you tap like this, all right, first tap, it will slowly increase one level of intensity, and again tap again, so it will slowly increase the tap. All right. So or yeah, whatever input you are trying to do, right? So you can try giving that. So all those actions can be converted back into the LEDs, and then you can try controlling it, right? So it's up to you. So as an AI guy, right, you would be doing such kind of operations at the back end, right? So you would be doing that. So here is a place where you have to remember that PWM pins will help you to provide the analog outputs or the variable output to the pins to provide the intensity and increase the intensity and decrease the intensity of the LED. So if I'm talking about the intensity, It can be anything, right? For example, if I have to control the speed of the motor, it's the same. PWM signal is applied there, right? So it does the same job for me, right? We can use.
Is the difference between GPIO pin and PWM pins?
Yes, this is.
Oh, it's with one pin.
So some pins are, see, you can see it here, right? So GPIO pins are regular pins which are available. So all the regular pins. See, we have multiple operations on a given pin. You should observe that, right? So here, if you observe 14 and 15, right? They are acting as an UART communications, right? UART is nothing but universal. So when you have an external module like GPS module, SIM module, you are trying to connect that and then do this job, you're going to use UART communications, right? So for example, you are trying to use SPI kind of interface. For example, you are trying to deal with a Nokia small display and do the whole thing, right? Yeah, the same interfaces can be used. These pins are dedicated for that particular purpose. For this, yeah.
What is PWM? Why you configuring GPIO as a
PWM pin, yes, okay.
Default GPIO you use.
Yes, that's nice. So that's a good question. So by default, all right, any digital pin can take high or low values.
GPIO.
High,
Yes. High low.
High or low values, right? So previous example we have seen it.
5
We have
volts,
switched on the LED and we have switched off the LED, right? But here in this case, I want to give a variable voltage to that. Variable voltage means I want to control the intensity of that particular LED. So in that case, only PWM pulse width modulations. Those are nothing but the modulation is done at the board side. Only those signals can be sent through PWM, dedicated PWM pins. So we have what we have here is we have 4 dedicated pins. Only you should think of those PWM pins and then try to do the job. Perfect. So you have to remember these things. So small things, but they'll make a lot of change.
They have to connect only on that.
Yes, exactly, exactly. If you are dealing with such kind of applications, all right, so you should do that. And then, so here is a way. So here is the way he has done. So he has connected the ground and then a digital pin. So and then he has tried to provide the variable voltage here. So yes, it is done all. Okay. So
What is meant by
GPIO is nothing but general purpose input output.
And GEN is for GEN is for
GEN.
yeah.
Where do you see that?
I have seen on the boards GPIO 16 to
You're talking about this?
GEN Gen no, in that 13 11 13 15 pins board
Mm-hmm.
not this
You're talking about this?
yeah not this 13
Yeah,
11
this is general purpose, buddy. So you can use it for any purpose.
two means both are only GPO is general purpose and GN is also
No, no. So see, for example, here is the case. So what he is trying to give is, so there are multiple operations on a given pin.
yes
Right. So here it can be used as a PWM pin as well as a general purpose. Multiple purposes. So here, can't I use 14 and 15 to control an LED? Yes, I can do that. It can act as a GPIO pin as well as a RX and TX pin. Say RX and TX being the priority, but if you are not using for RX and TX, you can use it for the same thing here also. So either you can use general purpose or yeah, yeah. So you are going to use. So gen is having a different specific meaning that I'll explain you later. Right. So you don't have to.
there is a difference between
Yeah, there's a slight difference, but not major. So in case of you're trying to have an internal resistance, so which will help you with that. So to suffer to sustain from the external high voltages. So if I explain you that here, so you won't understand. So that's the reason I'm skipping that. Right? All right. So any other questions here so far, folks? All right. So when you come to the GPI programming part, here is it. All right. So PWM pin. you are trying to set all the warnings, like so the board mode and then the output mode, and then so the LED is been put into the output mode, and the LED pin is being set into the PWM. Okay, so PWM and then 1000 is nothing but the frequency of that particular operation. So 1000 being the operation frequency, and then you would be starting that from 0, so it will go till that particular value and then try to do that job. Right, so the wavelength will be given to you, and then duty cycle will be provided. So duty cycle is nothing but the range from 0 to 100, and then I would be providing that to that particular value. So that is like it is slowly increasing and slowly decreasing, slowly increasing and slowly decreasing. So here in this case, on the other for loop, right, you would be seeing from 100 to -1. That is nothing but 100 to -1. That is like 0 in this case. All right. So this loop is continuous. This is like an infinite loop. While true is nothing but an infinite loop. Whenever you invoke any Python code, right, it keeps running that particular while loop forever, unless you do give an external interrupt from the keyboard, and now you're going to look into that. Right. So this GPIO pins will help us to control any LEDs or any other actuators or sensors which are having in this case. Right. So this is a pretty simple, straightforward, guys. You'll be running that values and then trying to control those things in this case. Okay. Any questions? All right. So if you want more details and if you want to look into dive in depth, you please visit this particular website, so wingscom.com. But I would be giving you a short notes on this also. So the one which I have given is having little notes, and then I would be giving you this notes also because this is a little high level. You can't understand some of the terminologies, but I would be giving you that coding as well, right? So any questions, guys?
This sample what you are trying to do is just to having a display indicator on a chip. I mean, what is the kind
Small
of
LED, and then yeah, I'm trying to increase the intensity and decrease the intensity. That's what I'm doing with respect to the PWM. So in future, like whenever you are trying to deal with the this kind of concept, right? So this kind of things. For example, let's say you are planning to build a rover. So rover, right? So you can't run it at a speed of like a jet speed. You should slowly take that particular thing and then do the work. So if you want to apply the signal at a given strength, you can apply this particular using PWM. You can slowly increase the speed and then slowly decrease the speed. So and arms also, right? If you want to move the arms, you cannot do immediate action, something like this. You need to have a smoother action, something like that, right? If you're trying to control an arm, you can do that. Even the conveyor belt also slowly increase and slowly decrease, right? So something like you would be doing that, those kind of operations continuously. Okay. All right. So any questions, folks? Any other questions so far? All right. So we'll be slowly dealing with connecting the sensors and doing the work. So on this Saturday, so if possible, oh, not Saturday, not this Saturday, on next to next Saturday, all right. So like we'll be completing the complete syllabus, all right. So and then we'll be heading into the workshop, all right. So workshop where you would be working on the area, like for example, you would be taking in a project, and then we'll start working on those. So, and then you would be working on how to control the things and how to do the work. We'll take some sample examples. I already have some few examples which are connecting AI and IoT. So you'll be taking those things and then you'll be working on those applications. You'll be running those applications on the Raspberry Pi and doing the work. All right. So that will be dealing with the things. Right. So as of now, we are planning to do the work on the Raspberry Pi itself, right? So we are not going to do any work on your computer. You would be writing the code on the Raspberry Pi, and then you would be doing the work. So that is available. And next thing is, all right. All right. So any other questions? I'm running out of my battery also.
Sir,
so it might.
PDF, the process changes.
Oops. All right. So any other questions, folks? So you can see the LED, right? So whenever the pulse width is too high, the intensity of the light is too high in this case, and then whenever it is low, the intensity of that is very low in this case. Okay.
According to width of the
Yes, exactly. So according to the width of the pulse, you are going to do that job. And next thing is the UART communication, guys. So when you talk about UART communications, right? So this is like an universal asynchronous receiver and transmitter. That is nothing but when you have an external module like GPS, all right? GPS is nothing but not the one which you have on your mobile phone. This is something different. This would be directly connecting to your satellites and getting the will get the position of yours. Right? So something like, for example, if you are, I'm here right now, seated in my place. Even if I take a step next, right, move next, it will give me that position changes also. Right. For example, this is not available in your mobile phones. Why? Because whenever you open your mobile phones and Google Apps, right, you would see a big round around you, big circle around you. That means you are somewhere in that circle. Not exactly, but with respect, when you use GPS, it will give you exactly where you are, at what height you are also. Even that data is also available.
Why they don't use them?
Why they don't use in mobiles means the very first thing, it is bulky, right? So we in mobile phone you cannot have that thick round thing, right? So big round thing. So there is one missing right now, but let
And
me show you.
connecting to the satellite is free.
Yes, free of. This is such big. This is a GPS chart. And if you want to have this big receiver and then this big sensor on your mobile phone, that is quite difficult. That's the reason the one satellite phones have this particular thing. So guys online, I'm just opening my camera, and I would like to show you that GPS chip. Right? So just have a look at that. All right. Hope you are able to see. So this is a big GPS chip, and then this is the Raspberry Pi, which you are seeing, right? You'll be seeing this, and these two will help you to do that particular job. Right? So here I have connected one of the sensor. This is a gyroscope sensor, wherein you would be getting all the tilted angles and all, right? So if you are trying to do a case study on the bikes, right, how they are trying to do the work and all, right? So especially like when you are dealing with the accidents and all, you want to do the accident detection. This chip, right, whenever it is in this position, it is a stable position. Whenever this particular sensor goes this way, right? So whenever bike falls, the sensor also goes this way, and then it will generate alerts saying that accident has happened. Something like that. So we have multiple conditions also. You can try looking into that areas as well, right? So this is the best chip which I can see, right? So which you can try, right? So guys, folks, I'm just closing my cam as well. So fine, guys. Thank you and have a nice day. Bye bye.